Good evening, everyone. First time I've been here. I don't get along to Thursday nights very often, just due to work commitments, and by the time I get home and back here, it would be a bit late, a bit difficult. But I'm glad I was being invited along. So this is probably the first talk on Tesla I've given, like apart from speaking about various aspects and at ASTRO. I recognise some of you from ASTRO. So we'll get into it. What I've got is I'll read out a little bit of text first, which will be the boring part, and then I've got another presentation where there's pictures, and we'll go through some of his apparatus and what it does and some of the misnomers about it, and that should just about wrap it up. Okay, so I'll read some of this out, and we'll hopefully that's not too boring, but we'll go for it. So Nikola Tesla, born on 10th of July in 1856 in Smiljan, I think that's how you say it, part of the Austro-Hungarian Empire, now known as Croatia. Nikola was the sole surviving son of his father. Brother Dane died at the age of 12 after a horse riding accident. I think that gets forgotten about that he actually had a brother that died early on in his life. His mother, Giuca, Nikola attributes his prestigious talents to his inheritance from her. His mother, that's who he claims he got all his smarts from. The Tesla family business was the priesthood, and in which the career path that his father wanted him to take. Though after attending college or high school, Nikola became fascinated by electricity when his physics teacher demonstrated a dynamo device that produced electricity. Following that, he longed for experiment and investigation into electricity. Nikola was struck down with cholera shortly after his brother's death. His father promised Nikola that if he recovered, he could study engineering at university. So after a 12-month recovery, he began studies at the Austrian Polytechnic in the city of Graz. An argument and mocking took place from a professor over a DC dynamo, where Tesla dared to suggest that a metal brush commutator was inefficient and unnecessary. This evolved an interest into motors and AC generators. Tesla never graduated from Polytechnic, even though he could do calculus in his head. His first year grades were outstanding, nearly working himself to death. However, by the end of the second year, he had developed a gambling problem. And if you read his autobiography, that comes up a bit. He lost his scholarship, and by the third year, he stopped going to class entirely. And there's probably more of a story into that too. Then after his father's death, he tried his luck at formal schooling once more, where he also studied languages, Latin, Italian, French, German and English, in the city of Budapest. He fell ill again, and after his usual exhausting work with symptoms more mental than physical, he became hypersensitive to sound, no matter how small or distant. Oh, you can do the next one? So one February afternoon, after a walk with a friend while watching the sun go down and quoting Goethe's Faust, Goethe? Thank you. Goethe, yes. He seized a stick and began to draw in the sand, which appeared to him in a flash. The design for an alternating motor in which a rotating magnetic field produces rotational torque that can be used to do work. He declared, "No more will men be slaves to hard tasks. My motor will set them free. It will do the work of the world." In 1884, British-born inventor Charles Batchelor brought the promising young engineer to the United States, and Tesla set up a laboratory in Lower Manhattan and quickly filed for patents on new types of AC generators and motors. Tesla's great innovation was to take alternating currents that were a quarter cycle out of phase and feed them into different coil sets around the rotor. Tesla met Edison on a couple of occasions, but never worked with him directly. Tesla was not happy in Edison's machine works in Manhattan, where he was assigned to work on arc lamps. The manager offered Tesla $50,000 for his designs for new types of generators and other devices, but Tesla reneged. Tesla learned the harsh lessons of American capitalism, and that investors care more about profits, not innovating for its own sake. And Tesla quit just after 6 months. In 1888, Tesla demonstrated his motors before the American Institute of Electrical Engineers. His showmanship and novelty for the invention impressed the onlookers, as Tesla had done what no one else was able to do. And George Westinghouse took notice, and Westinghouse licensed Tesla's design for $60,000 plus a minimum royalty of $15,000 a year. The current war then ensued, Tesla's AC versus Edison's General Electric DC. Tesla's AC had the advantage that it could be transmitted at much greater distances and at higher voltages than DC. At the receiving end, a transformer can step down the current for a user to power whatever device they wish. Edison's DC required frequent maintenance on the commutators and only worked in dense cities, since the current could not be transmitted more than a mile. Though the downside of AC, high-powered transmission lines were dangerous, which led to highly publicised deaths of utility workers. Edison backed demonstrations euthanizing stray dogs and animals, including an elephant, and leading to the invention of the electric chair using Westinghouse's AC generators. However, when Edison's backroom dealings were exposed in 1889, it backfired, and bad publicity falling upon Edison.
Backroom deals?
Yes, backroom deals.
Monopolisation of other people from behind the scenes.
Yes, that all came out. In 1892, Westinghouse outbid General Electric for the opportunity to electrify the world's Columbian exhibition in Chicago, where the modern marvel of Tesla's AC system made their debut. In 1893, Tesla was consulted on building a power plant at Niagara Falls. So Tesla remained unmarried, and his chastity contributed to his creativity. The 1890s were where Tesla had a productive time inventing and discover of new phenomenon, including radio frequency transmission, X-rays, although they were invented, he experimented with them, oscillating AC generators, circuit controllers, wireless induction lamps, and including the famous high-frequency Tesla coil, first tested in 1891. In 1895, fire ravaged his New York laboratory, destroying $50,000 worth of notes, materials, photos, and prototypes. So that's a bit of a shame. Imagine what we might have seen from that. And I wonder if that fire was deliberate. In 1899, Tesla moved to Colorado Springs, where he set up a high-altitude testing station in order to continue his distance transmission experiments. Returning to New York, the financier J.P. Morgan provided $150,000 and began planning his greatest project ever, the Wardenclyffe Tower at Shoreham, New York, Long Island. The tower was meant to transmit telephony, images, or even power as claimed by Tesla. In fact, it was going to be set up as his worldwide power grid known as the World System. The tower was only activated once in 1903 and was the beginning of Tesla's undoing. The project fell apart by 1906. Among other tragedies, Morgan would not advance any more money, and Tesla had ran out of money and financial backers, and by 1917 the tower was sold for scrap. Tesla was not out of ideas though, notably bladeless turbines and air friction speedometers, but failed to sell them efficiently. Tesla wrote his autobiography in 1919, and Tesla's final years were spent feeding his beloved pigeons, obsessively washing and obsessing over the number 3. Hence, that's why I've got Tesla 3 as my number plate. He rebuked Einstein's theory of relativity, or even that electrons are one of the primal components of atoms. How dare he, yes. On his birthday from 1931 to 1934, he gave an annual press conferences where he claimed to have new discoveries, including cosmic ray engine, found a new form of energy, and a fantastic claim of invented teleforce. Teleforce. We don't really know what that is. In fact, from 1919 through to when he's died, all that period is we don't have much information on.
Sounds like radar being used as a weapon.
Yeah, possibly. So-called is death ray and all that sort of thing, which I'm not going to talk about that because we don't have accurate information. In 1937, while crossing the street, Tesla was hit by a taxi. Refusing medical attention, his health declined. He was found dead in his room. This is 5 years later after the taxi incident though. In room 3327 on the 33rd floor of the Hotel New Yorker. His ashes remain at the Belgrade Nikola Tesla Museum. With an estimated 300 patents bearing his name and other important discoveries and many written articles, Nikola Tesla is one of the greatest inventors of all time.
I would dispute that last line.
How about greatest electrical inventors of all time?
Not one of.
Okay. Well, some people might argue Thomas Edison, but Tesla's number one in my eyes, so sure.
Did Edison finish up with 300 patents?
He had a lot, and there's other people that have had, electrical people that had a lot of patents too, but no doubt Tesla's were some of the most remarkable, radio being one of them. It wasn't Marconi, but Tesla invented radio. So, yeah, and that period between 1919 and until his death is really unknown, and I hope that one day it is revealed. I'm sure when he died, the government came in and took all his papers and materials, and I'm sure they have it squirreled away somewhere, and I'm pretty sure that's, forms the backbone of the, black projects that are hidden out at various military bases that we never see the light of day of.
Apparently when he died, he had chests about this big, about 30 or 40 of them in his room, and they took 90% of them and just left a few.
Wasn't the electrical engineer that worked through Tesla's work also Donald Trump's uncle?
Yes, that's true. Donald Trump's uncle, or
His uncle didn't like his father, but his uncle. And he was the main engineer that went through all Tesla's stuff.
yeah, he was an inventor in his own right, or as well, or maybe stole the things, and he came up with a variable sort of high-speed capacitor that would generate power. But that's
That period when he was reinventing, 1850s to 1900, was also the period of time where in Melbourne was, the richest place in the world for four decades. And so there was no shortage of people who were inventing stuff. And I believe that was when that guy invented refrigeration in Melbourne. But was there any other inventors? Because they could have imported all that sort of stuff. They had no shortage of money. But we don't hear anything about Melbourne about that.
okay. We'll go on. So this is the part I'm not going to read. This we're just going to ad-lib it the best we can. So, who is Tesla? Tesla is not Elon Musk. Tesla is not the electric motor company. And has Tesla Motors hijacked Tesla's name? Question mark. So I get asked, maybe we all know perhaps who Tesla is, but I get asked by little kids around school and they see my number plate and they carry on and they say, oh, Tesla, and that's that SpaceX, the rocket guy, and it's no, kids, no, it's not who Tesla was. Tesla, you know, Tesla Motors uses the name Tesla, but it comes from the inventor. Here is the real Nikola Tesla. And this is Tesla's logo.
Is that his family logo?
Well, that was his logo that he did set up a company at one point, and it was that was the logo, NT, Nikola Tesla.
It's like an N and a T.
Yeah, it looks at there's trucks that get around called, I think, Nuriopta. Used to be Nuriopta Transport, now it's Nuriopta Traders, and on the back of their trucks they've got a big NT like that, and I always think of Tesla when I see their trucks, thinking it's the NT. So then we're going to get on to his first invention, which is the alternating motor. And it's got the famous X through it here in this one, and this one's got more brushes. But pretty much the opposite phases are 90 degrees out of phase, and to cause the rotating magnetic field, which he claims in the end was still his greatest invention ever, was the discovery of the rotating magnetic field. He said, which will carry on forever. So this one here is one they dug up recently and confirmed as the original in the British Museum, one of Tesla's AC motors. And this one, we believe that's Tesla's motor, but I don't know that they really... No, that's not the Niagara Falls one. I don't have a picture of that. They're a lot bigger even. They're huge.
How did the British Museum get their hands on it? No?
Sorry?
How did the British Museum, how did they end up in the British Museum?
Well, he spent time in Britain. Yeah, before he came to, like he said, he met Charles Batchelor in Britain, and he brought him over to the United States.
British paid for it to immigrate to the United States.
Yeah, so he did spend time there. So let's talk about his high frequency devices, which we've got some of here. So this is one of the first ones that he discovered some of this, corona discharges with. And here you've got just a wooden former, and these large circles here represent the coil of the primary coil. And then it's on a sort of, there's twin formers here. So this one here is, all these little circles here is lots of windings of a thin, small coil. In other words, like a step-up transformer. And all of the connections come off the top. Importantly, it's in a wooden box and it's filled with oil, or a form of insulating material. We believe it's oil. And he's called this his disruptive discharge coil, because being under oil, it wouldn't burn out. And I think in here, when you read the text, he's got layers of cloth and all sorts of stuff here between the layers so that they don't short out, and it's the oil in between. So it's highly insulated, the windings. And this is the circuit of the basic setup that he used for the next experiment. So he had like a generator here, just a normal AC motor generator usually, that fed into a capacitor. And this, he could have had one capacitor, but he split them so that they've got a dual feed sort of symmetrical capacitor system. And it goes into the primary. These could be linked or unlinked, or you could do whatever there. Into the primary, and then the spark cap here. So the spark cap would fire. You have a huge, and so this forms the tank circuit of the capacitance and the inductance P and the capacitance. You get the tank circuit, fire it in, and you get a huge rising current which generates generates your voltage in your secondary coil and steps it up to a huge degree, and as a high frequency coil. So that's what he called his disruptive discharge coil. What was disruptive about it? So these are early examples of a spark gap. So when you have a normal spark gap that it jumps across the air, and you can make standard Tesla coils with just a gap. But Tesla found that that wasn't disruptive enough. And what he found is he'd have a spark gap between A and B here, and he'd have something in there to stop the arc, or to blow the arc out again, because, well, as the energy would jump from one terminal to the next, it would actually ionize the air in between. And as it ionizes, it starts to sort of make it conductive as it goes. It's a resistance, and so it's not sudden enough. It's sort of a slow jump because of the air's ionizing. Whereas he found if you put a magnetic field in here, these electromagnets actually, here it shows the electromagnet. If you put a magnetic field here, or in this case, he had a jet of air to try and blow the arc out. When it did finally jump the gap, it would be more sudden and have a direct, it's either on or off instantly, or more instantly than just an air gap. And before this, he didn't see it, he'd have multiple gaps in a row, like 2 or 3 or 4. Today, when kids build Tesla coils out of neon sign transformers, they'll use multiple gaps in a row, and that sort of works, but it gets the result, but not when it's super sudden. And when you get it and you'll get sparks, no matter what, but when you get it in a ultra sudden system, you get different results, different effects. And he goes on to show some of these effects and describes how you'll get different coronas coming off the terminals, and these are drawings out of his book. So discharge between 2 wires with frequencies of a few 100,000 per second, and the effect produced by concentrating the streams. So these are drawings, not photos. And he goes on to say with this disruptive discharge, he gets what he called phantom streamers. And we don't see them very often. They have been replicated, but these phantom streamers are more unique. And you get luminous discs. They're drawings, of course. This is kind of more, well, it looks like they're still black and white photos though. But you get this arc discharge and you get this streaming in between. It looks quite beautiful. It's more like this, more like just standard blue, purple, pink discharge colours of your corona. And then, so what is it useful for? What does this high frequency stuff do? And he found that he experimented with lamps, because it wasn't, there wasn't a lot of developed uses for it as such. We know it can use for surgery and all sorts of things these days, but he started off by using lamps. So he did a lot of experimentation with lamps, and he had there's chapters all going through how he'd exhaust lamps and get them without the air, and eventually experimented with little carbon buttons that would luminesce and create a light. An interesting thing about these bulbs is just one wire. There's only one hot terminal and creates the effect, and that's it. There's no return wire. Well, the return wire is the outside. And here's another, you can't really see it too well in this, but another purpose was he had it inside of a tube, a metal tube, with a motor blowing air through here, so it would be a good generator of ozone. So this is apparatus for producing ozone gas. And just with these coils, if you get close enough, you can smell a little bit of ozone. So then we start to he gets the next step. The next step in his evolution of his devices, and is the means for generating currents, and that's all it's entitled. And this one here, means for generating electric currents. Number 514168. And he also started designing these high frequency coils, high frequency, high voltage coils, and in the end here he had serpentine widenings. Instead of his stalks, they would sort of S around in a snake-like fashion, and that was good for producing high voltage, high frequency currents that he wanted. So The difference here though, in the circuit, we've still got the generator, it looks like, down here. But what now he's got his capacitor, and I didn't include this in this presentation, but he's designing capacitors that are in oil, and they're adjustable capacitors, so the plates in oil can move in and out of each other, and you can adjust the capacitance for the particular capacitor, and that way he could tune more accurately his capacitors and his primary coil to get a more resonant effect. And you'll see here now this coil here, the main discharge coil is in this bath of oil. And look now, also this spark gap device is also in the oil. So this is the enlargement of it. So it's a little a rotating gap that goes around and around and connects the circuit that causes the disruption and causes everything to happen. And then this oil tank here is filled with oil. Oh, sorry, not filled with oil, filled with water. You can see the coil inside is the oil that circulates around there to cool it, and then it goes through and it's pumped around in a loop here. We've got this little pump here. So he's got cooling oil, and it also serves as a coolant and also as an insulator, and keeps his sparks disrupted. So then he started to make some progress there. Now this.
Michael, can you look on the previous slide there, at the bottom there, that's high voltage, what's that serpentine there in the brackets for?
Because it's the way it's wound here. It's like in an S shape, like it goes around in an S, right around the external perimeter of the coil on that particular design. So here, this just shows, this is not a very good picture of it, otherwise I could explain a bit more. But in essence, you've got here, this is a generator. And on here, you've got off the DC side, coming over here, and then off the AC side, it comes over here. Funny enough, some of his biggest effects, or method of conversion that he called it, taking low voltage DC or low voltage AC and stepping it up and getting this high frequency stuff, or converting it as he would call it. He found these methods were the 6 main methods he used. So in the AC side, it's pretty much what we saw before: a tank circuit, spark gaps, adjustable capacitors, things like that. And over here on the DC side, he had a couple of different spark gaps, and basically that was it. And here he had a DC generator and a step-up DC generator. This here could have been the serpentine winding, or it could have been another generator. I'm not quite sure what that one is. But then the same sort of arrangement. And then this one here is a DC motor, stepping it up to AC and basically copying what was over here. There's some Tesla experts rant for hours over this one, but I'm going to just keep going. So after he got these disruptive coils happening and bigger and bigger power, the serpentine generator, he got more effects that were seen in the books, and bigger coils too. So here he is doing his showman routine. I'm not sure what's going on with this big light. I think that might be some kind of, it's not really described. Maybe he's moving his wand around and it's here he is with one of his bulbs.
Was that flash that generated from was it flash generated from what he was doing, or was it from the camera?
Oh, the previous one?
Yeah.
Well, I don't know.
You're not sure.
It looks like he's doing something with his hand.
Yeah, he's holding a stick or something.
Yeah, he's definitely holding a stick. This coil here is illuminated. You can see it's glowing around the edge. He's holding onto it, and I think the currents will be going through his body and coming out this side. Here he is here with the glowing stick, glowing light bulb. This one here, you can see doesn't show much, but it's got a couple of loops around his high voltage coil, and he's got a little light bulb on the end. So this probably got to start thinking in his mind about wireless power, wireless technology.
looks like he's demonstrating that this electrical energy is dangerous by using his body as a conductor, isn't it?
Yeah, well, the high frequency thing passes through you. It doesn't always kill you. So this is Mark Twain. This is his friend, and there's a lot in the biography and books about Mark Twain. And of course, Mark has his own story. So and this is where we start getting into some of the big power stuff. This is the big breakthrough that he had, was more of the disruptive discharge, the circuit breaker controller. And this is one of them. It's not the only one, there's lots of them, and they're quite complicated devices. But in a sense, what it is, he has a pool of mercury that gets drawn up, and this is a motor, so it spins. And so the mercury gets drawn up and it's shot through a jet, and it makes and breaks segmented sections at certain rate. And I think these segmented discs he could alter and so forth. And otherwise it's in oil. So it had a mercury oil circuit controller. So because there was no air and mercury had certain aspects about it that would allow high current, instant make break of a high current system. And that's what would be switching some of these incredible powers, these mercury circuit controllers. So once he got to that point, he had some spectacular results in his lab. Coil's absolutely going crazy. But then he started to realise something. And then he started setting up in Colorado Springs. And this is the first circuit that we're talking about with called the system of transmission of electrical energy. So let's look at it. We have this here is his generator, and he's omitted all the coils and I guess you could say capacitors and circuits that he's used for that. He's omitted that, and he's just left it as G, as a generator. And that goes into his primary coil. It's usually just a few windings of his primary. And he's got his secondary coil, which is multiple windings. And one end goes up here to the D, which we call the elevated capacitance. And then the other end goes here to the ground. So I guess one of them, and that's all very good. And you've got a similar system over here, where this coil receives the energy and then into this secondary coil, and then the energy is then translated back through the primary coil and then used here in motors or lights, or he had various things. So he could transmit the energy from this coil to this coil, one to the other, with one terminal. And this is the setup in Colorado Springs. That's not Wardenclyffe, that's Colorado Springs. And he had just a shed there, and he had his, this thing was on a mast, and this little ball that represents that tiny little thing up there, that could be moved up and down. And according to the wavelength or the frequency he was using, it was optimal to raise it higher or to raise it lower to get the resonance that he wanted. Of course, this here is, you could say it's interacting with the atmosphere, but we will discuss that a bit further in a minute. So this was in Colorado, inside the building. You'll see this is where he's starting to generate some absolutely crazy, out of this world energy as far as frequency goes. This is an actual double exposure. It's not believed that Tesla's actually sitting there, getting zapped. It's a double exposure. They were playing around with photography at the time, and they worked out how to do double exposures. But nevertheless, it does show the coil operating. Now, some people don't realise, maybe you do, but this is the third coil in here. It's the main coil, but it's not the only coil.
Are they real sparks coming out?
Yes.
Really physically see them, not just
Yeah, they are real sparks. That would be a photo of real sparks, definitely. You can tell the threads and the patterns of it. And it's actually, in this one, it's coming off of this output here. It's got the top turn, which wouldn't be a full turn, to be like almost a full turn. It's not a full turn, because if it's a full turn, it becomes a shorted coil. So the top ring is not joined. But he's got his arc coming off of that. So this one here goes in, and you can see this is the coil. This here was in the coil that was in the last picture, coming off here. But he's got this coil here, and he's got one here, and another frame thing here, and he's got all sorts of, and over here he's got all these sorts. Now, these are all being energized, not by this coil. They're all being generated by the secondary coil, and the secondary coil is this great big thing here. This is not a fence. This here is the secondary coil, and also the primary coil. So the primary coil and secondary coil go right around here. It's huge. It's like 50, nearly 60 feet in diameter, this whole big coil here. And this one here is sitting in the middle, and all of these here are sitting within that one as well. So they're all firing together inside this coil.
Is that double exposure again with him sitting in there? Or?
Most likely, but this one isn't. This one isn't.
That would have been too dangerous to be alive in there.
Well, I don't think that the energy would kill him because it's high frequency, but he would certainly get radio frequency burns, and it would not be nice. So here's what's going on. Now, a friend of mine called Simon, or Dr. Green, Dr. Green, he makes these little coil kits here. But what it does do is show the model of it. So this is a working coil down here, or working model, crafted for the ham radio frequency. Okay, so here you've got the outer coil and primary coil at the bottom, and you've got this top one, which is like we've seen this one here. And then you've got the extra coil. So this thing here, this third one in here, this here is called the extra coil. Or sometimes it's called the magnifying coil, or altogether it's often called Tesla's magnifying transformer. So all three coils together are called the TMT, or the Tesla's magnifying transformer. It's actually three coils. And then this here goes to this, it couples to this, and then that mast is what's going up outside the building to the sky. So then comes the next step. He packed up from Colorado, and he went back to where it was reading the notes there, but he packed up from Colorado and then set about setting up the next thing, because he proved what he wanted to prove here. And I think also he blew up the local energy transmission system, and so they weren't happy with him. So he moved to, started setting this up out at Long Island, Wardenclyffe. Yeah, I'm not sure. Yeah, their local supply generator, that he knocked it out.
That would have been based on DC, yeah?
It may have been. I'm not sure on that particular fact, but he would have used his generators to transform it into whatever he wanted anyway. So this here is, again, very similar to what we've got, but I'll explain it a little bit more. So, in a sense, we've got this here is the extra coil now. It's not, rather than short and fat and stubby, it's more of a long, skinny one in this particular schematic anyway. Here is the secondary coil, which is a bit hard to see, but it's in there, and the primary coil is around the base. And then here's the elevated mast, and it comes up to this thing on the top. And this is the top terminal capacitance. And you see on here, it's got lots of little spherical metals plates, all dotted on there and placed on there. And that is to increase the capacitance of it, and also to try and stop the sparks from jumping out. Because one of the misnomers, which we'll get into next, is about the sparks. So this is more or less what it looked like. He had his control building, he had the tower and the ground system, and all of the interconnected electrical and water services and things that needed to go to it. So this was going to be the beginning of Tesla's world system, the first station, the main generating station. And then there were supposed to be others built at certain nodes around the planet or at certain spots where this would couple to and then keep feeding the system. So this is one of the misnomers I wanted to talk about. Everyone thinks that when they see Tesla coils and they see all the sparks coming off the top here like this, that the energy is somehow transmitted through the air. And here's the energy and we receive it like a mobile phone reception or like radio or anything like that, and you've got flying machines around it. This is an artist's impression. And that's not really how it works. There is some sort of interaction with the atmosphere and cosmic rays or whatever you want to call it, or some sort of capacitive coupling to the atmosphere. That is true. But when you look at the conductive sort of section of the planet, it's only a very, very thin slip of conduction in the atmosphere. When beyond up in the sky, it's rarefied and it's not really, and it's reflected off the top, as we know radio waves are. But a lot of people think this is how it worked, but that's not. So we'll go into what it really is about.
The design there looks very much like a mushroom or the modern day microphones as well. Is that would the microphones be based on that design, do you think, or are there any?
No, I don't think there's anything to do with microphones in this instance. These spherical spheres were just to stop, because I guess what he was after was like maybe a glow or an ionising section around, near the surface of it, because of course there would be. But he doesn't want the energy to spark out like this, because any energy sparking out is lost, wasted energy to the atmosphere. It's just it's not working.
Those many spheres of that basically, that's exactly what we'll do with extra high voltage testing place, where they test extremely high voltage cables or whatever. And so to make the volts per meter, the electrical intensity as small as possible, so they don't get sparks coming off. So that's why they've got lots of those little hemispheres all over the surface.
Yeah.
There's also a reason why the shape underneath it is like they've got it to try and make the volts per meter intensity as small as possible. It's geometry thing, in other words.
Yes. Yep. Indeed. So this is what's speculated, and if you read some of the notes that he's got on this, and he describes the underground system for this is very, very extensive. So it almost goes as down into the ground as it does on top. And he calls this to get a firm grip of the earth. So what's going on here is there's a staircase that goes down, and on the original site at the moment it's caved in and I've sort of cemented it over, but it would be good to see what's down there. But it goes down into the ground, a long way into the ground, and he talks about these 4 radial tunnels that come out, and there's an outer raceway of a tunnel. So this is sort of speculation of what it looks like, because we haven't been down there to actually see. But there's an extensive underground system that is connected to the earth. And what the idea is, when this Tesla coil fires and you get an impulse comes up, it actually, you can say this top capacitance is what the energy pushes on or pushes back on, and actually get the pulse that goes into the ground. So the output terminal is not the top of the machine, it's down here. On this particular coil, which I've shown to work, the output is not the silver ball, although you bring a fluoride near it, it will light because there's the energy there, but the output is really this one. This one is the end of the coil. This here is what lights the light bulb with one wire going through your body. This one is the one that goes into the ground that can be picked up by another coil over there that's also plugged into the ground. It's the ground acts as the wire. And when Tesla found that he had enough energy in this system, it's sort of once you reach a critical limit of energy, it has enough energy to push through the rock and solid mass of the Earth. It treats the Earth like a big capacitor, and which this energy, and I come to call it the displacement current, actually works through the ground. So a more correct sort of image of it, which the History Channel has come up to, is more like an image of this. This is what you should think about when you think about Tesla's tower, is the energy going into the Earth, not out. And then to prove this more, when you look into this displacement current, we should call it, Tesla shows this in his book. So if you can imagine, here you have a ball, right? Let's say it's a metal ball or even a basketball, rubber ball, and you have these pressure gauges spaced all around the ball. They're all going to read the same pressure, right? Because the pressure is distributed evenly inside the ball. And when you pump air into it, in or out, it's going to, these little pressure gauges are all going to move around and they're all going to dance the same tune. They're all going to be dancing the same. And likewise, this is what this is showing. This energy showing up here is not being transmitted through the air. That's a reflection. It's being pushed into the ground.
It's transmitted through the ground to the other side.
Yes, so that's why it can be transmitted through the ground down here or over here. But the idea to have this one and to have another one that would couple it and it would sort of re-energize it, and it would be nodes where the frequency would line up and it would interact with it in a positive way. And also, which we won't go into, but the Earth's core plays a role here too. So you've got the Earth's core inside, and you've got telluric currents in the Earth, and it's said with certain pulses going in and out of the Earth, it can couple with the core of the Earth and the telluric currents to actually get an increase or decrease in power, you could say. And there is speculation that at Long Island he did manage to couple to this energy of the Earth and had tremendous standing resonant spark that was generated in his laboratory. And I think this is some of the reason why his project was shut down, because they thought that there was a possibility they could cause earthquakes, or more earthquakes, and literally split the Earth in half. And so a lot of fighting and going back and forth about that. You can see also, because the energy is in the ground and therefore the sea, you could use it to power submarines or boats that are on the ocean and things like that, with this energy, with the receiving coil that's tuned into it. So when you read this book here as well, Leland Anderson's one, in this there's a whole section in the back here. And it's in the back here, which is all about the court case that he was going into defending his Wardenclyffe tower. That's why it didn't destroy it straight away. He was in court fighting for the survival of his tower. And he goes on to say over and over again in this book here that the energy that he was generating in the Earth was non-electromagnetic, meaning it wasn't our normal electromagnetism. It was this displacement current that we don't know a lot about, or at least those.
Tesla invented that term, displacement current?
No, that displacement current is not, he didn't call it that. That term comes from, I think, maybe Steinmetz. Or capacitor current is another thing they call it. So then in 1917, the US destroys his tower, which is a bit sad. So that's gone now. I think the site has been taken over and they're trying to set up a Tesla museum at that site.
When they say US, was it a particular department, or was it the CIA, or who was it? Did they know exactly who it was?
I'm sure that is documented, but I don't.
When they say US, I mean some part of the US government.
Yes, I don't know who, whether it was a lack of. I don't know about that full story. I'd have to look into it a bit more. I don't know off by heart anyway.
So they were convinced
Yeah, so Tesla also couldn't get funding. No one else would back him as far as provide more funding. The government was worried about it, and
What evidence did the government give that it was going to do something bad, though? They would have had that some evidence to say.
well, in the books they also claim, or you know, they say, well, how can we meter this? How can we charge people? And that also come up as being a financial issue as well. So all of those things together, in fact, with other people saying, oh, you'll split the earth in half and these things, you know.
What's the date up there? Does that have the date up there? Is that 1917, the date?
Yeah, September
September
1917, yes.
Wow.
So I think you can get this article in a more legible print so you can read it. So that's about the story that I've got for you tonight. We've got young Nikola Tesla, just a few pictures of his through his age, and here he is in his prime. I have to ask Ken Wheeler, there's the actual book, the book that he's reading there. I don't know what it is now, but I do have a reference to it somewhere. There's a book that he used to read a lot. Here he is showing some aspect about the spark that intrigues him, or maybe he's not actually pointing to a spark like the text says, but maybe he's actually pointing to the coil, the secondary coil there somewhere. It's hard to say. So that's about it. Gone but not forgotten. Nikola Tesla, the greatest electrical inventor and discoverer of all time.
Do you think he was too far ahead of his time? If he was alive today, he would have been able to, apart from vested interest, do you think he would have gotten and achieved what he set out to achieve? Do you think maybe he was just, the technology wasn't able to catch up to his...
Yeah, he was certainly ahead of his time, yeah, definitely. And I think there was no one that really, you know, could keep up with him pretty much. And when he went on into, say, later years and saying about these, his teleforce and the other inventions he came up with. Now, there's other inventions that he did invent as well that I didn't talk about this, which are quite interesting, which is the Tesla turbine. People see the bladeless Tesla turbine that spins at an incredible rate, over 100,000 RPM easily. There are a few people experimenting with the Tesla turbine, finding different uses for it. The Tesla valve, which is a particular design of like a one-way valve. I think I've got it on my stick there. I can show pictures of it shortly. You also had a fountain, a Tesla fountain, which was a certain design of fountain where it would pump water up from below and would spill out over the top, and it was quite a pretty fountain. I've wondered why he made a fountain, but maybe it was for the pigeons, but I think there's more to it. There's lots of different researchers going around that you can look at, and if you want more information, of course you've got Mark Cypher who wrote The Wizard here. This is quite an interesting book about not so much the coils, but also about his other aspects, like his relationships and all the letters that he wrote between certain people, and some of this work at Niagara Falls and a whole lot of other information. It was a really good, famous book. This one's good in that it shows all the technical stuff like I've showed here, but it goes in, it's got the court case. It's the only book that has the court case in it that I know about. This one here was given to me by ASTRO, but it's autobiography of Nikola Tesla, and it's quite interesting there.
That's his autobiography, though.
Well, yes, yes, and it goes into when he was like a young child, and he goes into stories about how he used to catch frogs, and he used to catch frogs had a shiny hook, and he used to dangle it in front of the frogs, and the frogs would jump at it, and he'd hook the frog and catch the frog. And he'd go out and catch all these frogs and come back with a bucket full of frogs, and all the other local kids just had a few, and they wanted to know how he did it. So then he taught them how he did it, and then he regretted that because then all the kids went out and caught all the frogs, and there was hardly any frogs left. And then he thought, well, I made a mistake by telling everyone. And he talks about also how he used to gamble, and there was an island in a particular waterway that he would swim across, and the current would push against him. And one time he decided to swim across that he'd done before, and he was sort of gotten halfway along, but the current was much stronger than before, and it pushed him along, and he couldn't catch the island. It pushed him down the spillway. He was heading towards an untimely end, spilling off the end of this fall, and he was gripping onto the rock. And there was something about that particular episode that gave him ideas about electricity and how water reacts to current, or water as an analogy for current, and pressure or the flow is to do with voltage. And so he would cling to the side of the wall, and he found when he put himself flat, he would have little resistance, but when he put himself out from it, he would just get blown away. So that also helped him in his discoveries, just that little incidents like that he had throughout his life. So some of the other researchers, this is, of course, you can buy his book, the Colorado Spring Notes, where, it's quite very interesting. It's all in his own words, so it's quite a good book to understand. It's got all these measurements and a lot of the notes for all the dimensions and so forth for the Colorado Springs coil are in there, and where that scale size device comes up. And then we've got a few others. Eric Dollard, which I've talked a lot about, he's written a condensed intro to Tesla transformers, and he was one of the first people to prove and show about the displacement current aspect of where we got the terminals wrong, where it's not the top terminal, it's the other terminal. Eric Dollard was the first one to prove that by experiment. And then I guess you could say the latest person who's done an excellent job, probably almost going past any of the experiments that anyone's done, including Dollard in some respects, is called Adrian Marsh. He's a PhD. And you can find him at AM Innovations. Or it's actually...
What country is Adrian Marsh from?
I believe he's from the UK. Yeah, he's the UK. He's like a ham radio operator. But it's...
What was his name? Adrian Marsh.
Yeah, but if you can look it up, it's www.am-innovations.com, or just search Google AM Innovations. And he's got a heap of stuff in there, including replicating of Eric Dollard's famous fractal discharge. When you get the tuning just right, you get this incredible fractal discharge from a coil, and other transmission experiments, and his work is outstanding, along with his...
When you say tuning, what were they doing? How were they adjusting the frequencies?
Everything can be tuned.
How were they tuned?
Well, you've got all these components that can be tuned. Inductance is one thing. Inductance means how many turns.
So you can tune the actual coils so that they're in resonance with each other, so to speak.
Yeah, so the inductance has got to do with length of the coil, how many turns, and the spacings of the turns. So yeah, it also has its own internal capacitance as well.
So you can use variation capacitance.
And also your propagation speed also depends, so is different. So these long skinny coils are designed to have a fairly hot output terminal. And this one here is not, it's flat and spiral, and it's got a faster propagation speed or higher frequency, and it's designed for transmission and also ham radio techniques, and it's designed to work with a ham radio. I've got a vacuum tube ham radio unit that plugs into this on the 160 metre band. That plugs into this one and its matching one that will actually energise it to its resonant frequency.
So what were they talking about when they referred to Tesla's radiant energy? You talk about discharge current. What about radiant?
Yeah, radiant energy is to do with you're hitting things coming off of the top terminal. There's been when there is a light bulb put on here, and you get the filament, and you energize it, you can actually see the filament wanting to expand in the area, in the actual vacuum. And some people can feel this radiant force, or almost like a pressure coming off the top of it.
Because I remember reading that some of his latest very end demonstrations on a stage, etc., was him standing there and getting his body to glow and things like this.
Yeah, it's said that his body glowed like a neon, not like a neon light, and no one has ever been able to replicate that or has any idea what's going on, because his whole body was covered in this orange glow, not a green or a pink or whatever, it was orange, and no one knows anything about that. No one's
standing on a plate or something, but he could get himself charged up somehow.
Yeah, I don't know. No one's familiar with how that worked or what currents or what was going on with that. That's still a mystery. You know, there's things we still don't know.
In electricity, the 50 hertz stuff, I was commissioning current voltage transformers 6 kV, and these were approximate resonance things, and all these purple sparks were coming off them. And I was told I'd have to clean it with some alcohol sort of chemical. Someone told me, when one of the operators from System Control, for instance, said, if the purple sparks, they're low energy, but if they're orange sparks, that's really bad. That's you know, that's like a power follow on arc, so you've got to make sure you never see purple orange sparks coming off this thing. So
Right. Yeah, there is I don't have any here, but there is a different kind of Tesla coil you can make that's more lower frequency. That's like a high energy thing that almost has like a different arc, almost like a flame coming off of it. It looks like a flame, and it's super hot. It'll melt heaps of things, and it's like this often white color discharge. So that's another aspect of the coils that you can go into. I don't have any of those here at the moment, because apparently the capacitor that's used with those gets super hot.
have you ever heard of current Tesla coils? I read somewhere that someone apparently used current Tesla coils, and when they operated, the room next door, these knives and screwdrivers, they all flew through the air and got stuck in the brick wall.
Right.
What's this current Tesla coil?
I never heard of a current Tesla coil. I'm not sure what that is, but if you can find out, that would be interesting. Some of the,
Yeah, I've been wanting to find out ever since.
when I had these ones set up, and I can show a video shortly of these ones operating. I don't have the ham radio system and all set up for it at the moment, because I'm putting it into another, how can you say, I'm feeding the ham radio that feeds this one into a more beefed up power supply that's about 3,000 watts. Then that one will then feed into this. So basically boosting up from about 100 watts to 3,000 watts in energy. And it's all still I'm still building it, or I haven't built it for a while, but it's all on the wheels and on a metal frame. And that's where it's all built into at the moment. So to take that out of there was just too much to do that. So I've just bought the top bit. What was I going to say? I'll come back to me in a minute.
You can't, with the high voltages, you couldn't experiment with that guy Brown. That was the high voltage sort of levitation.
Yes, yeah, you could use that, but often high voltage levitation devices rectified as DC voltages. So you could rectify the output of this and use that, yeah.
High voltages, and they had just like umbrellas, I believe, like little umbrellas that could just float.
And I think a lot of Tesla's really phenomenal work actually used DC, so it wasn't AC anymore. It was high frequency chopped DC that would give the really impressive results. Chopped DC, yep. So let's...
Michael, also in that biography that you read out, I think the first slide mentioned something about high altitude work, high altitude frequency. So I wonder if anyone pick that up.
high altitude DC.
It has that structure with a long thing on the top, and that works at the bottom.
Yeah,
Oh yeah, well that's equivalent to this here. So that there is up in the air. So the distance that would go up or down changes the frequency of the coil. So you can add the capacitance to this, like make this ball bigger or smaller to change it, or you can actually raise it up and that will change it to some extent. So not so much of it's more of a fine tuning. So to fine tune it, you would raise it up or raise it down.
I just find it interesting that the H-shape biamplitude that shows up in HAA biamplitude research program.
Right.
That picture was from Colorado Springs.
And this does interfere with, when this is operating, it does interfere with things like TV reception, things like that, as you would expect. But I remember first knowing about this when I had it set up, and my wife started screaming about the lamp inside the house was flashing on and off. And it was one of those touch lamps, and it seemed to be interacting with the touch lamp, and it would just start flashing like wild. And then I discovered that I was looking through the window into the living room, and I could see the TV was going. And if I turn the system on low power, the TV would start to pixelate, as you would expect. But if I turn onto half power, it wouldn't pixelate anymore. It would just completely go black, zip, gone. And then when I turned it down, the TV came back perfect. And so I was just doing that, and then I was out there again one time, and I think the next day, it was the Saturday, and the football was on, and I think the Crows were playing, and I remember, because we were watching, I remember the neighbour who was just right next door, and I figured, well, his TV's probably been affected too. So I waited until, they were lining up for goal. Yeah. And suddenly I'd turn on the coil full blast, and of course it wasn't made to spark, it was silent, nothing, and the TV would go black. And then I'd wait maybe a minute and turn it back on, and the TV was, and you'd miss the goal. And I could hear some noises in the next door neighbour. And I did it again for the next goal, because it was fine in between. And then I could hear more noise, and by the third time he stormed out of his house and started coming out, kicking his car and swearing and cussing, and walked down the driveway, and I thought, oh, there's enough of that. Yeah. So let's fire this spark thing up and see what we've got here.
Michael, there's, I don't know if you saw it and others as well, there's a great documentary series on SBS. Just Google SBS Tesla documentary. It went for several episodes, and they had some pretty high-powered scientists and researchers going through all this work, and they tried to reproduce his work where they're sending electricity through the ground, and they had a globe going through the ground. They've got some marginally work, but not anything to what the Tesla did.
Yeah, it seems there's a lot of low power systems that work to a degree. I've seen one that's a fairly big coil that was set up next to a lake, and it had a boat running around in the lake but they got it wrong. They had it grounded and into the lake, but they still had this big thing on the top, and it was sparking, going crazy, and the boat was running. But if they had just tuned it a bit different so that it wasn't sparking and it was contained in the coil, you would get much more energy backflowing to the water to power the boat. Because when it sparks, about 90% of the energy is going in the air, and 10% goes back to the ground. And what you want is the other way. You want 10% coming to the top and 90% in the ground. Anyway, this particular one is a vacuum tube Tesla coil. It's different to a spark gap coil because you've got the big vacuum tube that runs it. So the grid is powered by, actually the grid, what triggers this grid, the output of the coil is not the proper output, the bottom is not used as an output. It's actually used to feed back to fire the grid again. So it's kind of like a self-resonance system to some degree. Well, actually, no, that top one there is the feedback coil. It goes back to the grid, that little skinny one on the top of the black. It's been a while since I fired this up, so it's not perfectly tuned, and I did find a few issues, like there's a little wire inside this this LED, I think, that's starting to get. See how the LED is not working? It's because it got zapped. And there's a little fire that's beginning to start there. But hopefully it works. I set this up for the Maker Faire as a demonstration, but I don't use it that much. So we'll see what it does. At low power, it'll start again. Yeah, we can turn that one off. That would be good. Yeah, so it gets the fluoro going. The spark there. That one lights up much better. And this one is pretty good as well. That's not its full power.
Would that be painful before you figure it out?
We'll have a look, eh? So you can, if anyone wants to come up and give it a go, you can come and touch it. It doesn't, if you just touch the top of it, it doesn't hurt so much. But if you smell your hand afterwards, it smells like cooked, burnt flesh. But, sorry?
That is pretty serious damage. High frequency AC, you know it's not protected, but still being burned.
Yeah.
It's dangerous.
Yeah, it does burn, yes. So you can, it's got a more, I guess you could say, needle-like discharge because it's a CW operation or continuous wave. It's not like a spark gap broad spectrum where you'd get the whole shower of sparks. It's more, oops. We've got some something breaking out here. I think there's something going on the inside here. Yes, and it also you get a bit of ozone generated from it. Yeah, I think I've got a bit of a shorted bit on the coil there. Yeah, it's starting to spark off the edge of that coil of the side. So I'm losing some of the energy out the top there. The vacuum tube, yeah, the plate there heats up. Yes.
Do you know what frequency it's running at? You say high frequency.
Yeah, I think this one, I actually have forgotten what the actual frequency is. I think it's around the 700 kilohertz, I think, on this one. I just wanted to try this. I don't know what will happen. Probably nothing will blow something up. Yeah, it looks like it's. Ooh. That's funny, the frame of my glasses just heated up. Yeah, it's just sparking to that one, to the primary. Oh well. to raise it up. Yeah, that's the idea. This can be lowered, raised and lowered to couple or decouple with the primary coil. Nearly there. You probably still spark the primary coil, I would suggest, but it's coming off there, but I would say it's not really tuned, but I think you could probably tune it, get it more optimal. You could say this is almost like the extra coil, where this is the primary, secondary, and this would be the extra, the third coil in the series. Oh, that's crazy. My glasses are actually heating up here. I felt like sparks on my nose then. Yeah, shorter turns on the glasses. That was weird. Never had that before. Yeah, these are metal frame, but the nose things are padded, but that was really hot. Cool. All right, so that's about the demo. So this one here, over here, this little coil here is like, I brought this along. This is usually like a battery powered. I'll hook this up to a 24-volt battery and you'll get a little spark off the end. In fact, usually I have two coils. I have this coil with it, so I've got double, but I split them up for, oh, look at that. I just saw that this coil here has been energized. There was a spark on there. Must be coupling with this one. Anyway, so normally it would sit like that, and you can. The reason I brought this in because it's battery operated. It has one transistor and a handful of components. You don't need this thing or this thing. I just added them in. Just a switch and a transistor. It has a basically the bottom of the coil feedbacks and triggers the base of the transistor to make a sort of self-running coil. And you can make a very simple thing like this that'll have a little spark that'll easily light up a tube like this. Yeah, I have got that on a little bit, but it seems to have. This one's, it seems to be coupling to this one, doesn't it? Like I said, I did see a spark because that's only on very low power at the moment. I did see a spark when I handled this the first time. It was sparking on this.
That device you're messing with turned on?
No, there's no power to it. There's no battery. There's a light? There is a light. There's an LED light in that thing, but otherwise there's no light. Yeah, it looks like the coil's picking it up, or some of the frequency. Definitely.
So ideally receiver.
Yeah, in a sense.
In a sense, it's the receiver from that. And you could then block it from it. What's the block? What's the block receiver circuit?
I guess this is radiating a fair bit, but again, the energy really is out there.
What sort of voltage is coming out of the output? Must be enormous.
The output, yeah, you're probably talking a few hundred, yeah, at least a few 100,000 volts.
You're getting arcs that are like that. That's got to be, I'd say, 500,000.
It could be, yeah, you could be right. It's not really hard, it's a bit hard to measure. Originally for the, originally I had this one set up, that would sit there. And with this one set up on there and properly tuned, sparks would be at least that big. So I started to get that going last night, but then I had a little bit of an arc or jump that was starting to short out between here and there, and I thought, oh, I'm going to put a hole in the coil. So I decided not to go with that idea. No, the best you can do is like a little, I guess you could say like a radiation meter to get like a. I've got a little device that has I guess like a meter in it, like a field energy meter, and I can just get closer and it helps you to tune the coil. So you can often you can't see any sparks, you just have it low power. You want to know if you've got it running or not. You can tune it with a field meter. So that's about it for the demo and talk. So any other questions? That valve is I believe it's an RCA 833A, which I bought on eBay quite a while. I keep that. I usually take it out for transport, put it in that box, and when I'm home, I just store it in the box. So yeah, it's I can't remember what I paid for it, but the valves these days, as they're getting rarer and rarer, they can pay some pretty high prices for a valve. Yeah, in the back there, there's those glass things are vacuum capacitors, because I figured that vacuum capacitors are usually very low in capacitance, but when you put them in parallel like that and you add them up, you start to get a better sort of capacity. And so that one's 1800 picofarads of capacitance, all of them together. I think they're 300 picofarads each. And but I used vacuum like don't have to use them. You could use a different sort of capacitor, but they don't fail often, and you can treat them like hell as long as you don't drop them. And electrically you can treat them like hell, and they're good. So for the Maker Faire and want to run it all day, back in the time I thought that would be best. Plus they look good. And I had them for another experiment that I had, so I'll put them in there.
Let's put our hands together for Michael. In appreciation, Michael would like to give you the certificate.
Awesome.
And also 12 months membership.
Oh, lovely.
There you go.
Thank you very much.
Thanks very much.
Thank you.